Nice. There I am. And I can hear myself. Hello and welcome on this very special evening. It's very nice to have you all here. We have a few people that are here physically with us together. You can always also see the people that are here online with us. And I expect some people to come in very soon, shortly. Um, Tonight we're having two very special guests, which are Gerard Kruisheer and Kees Kruisheer, and they're gonna tell some things about automation in aviation and in the maritime industry. And we do this here at the RDM, where Captain AI is also based, so the company where Gerard is working for. And right now we're in the loft, and what we try to do is to keep our distance and have a very nice evening together with all of you. A few things I think that are nice to know, handy to know. Uh, if people are online and they're having questions about the topics, one of the things that's been said, just raise your digital hand, and we'll make sure that you can ask your question. For the people in the room, well, I guess you know how it works. You've done this before. If you have a question, just raise your hand. I'll come up to you with my beautiful microphone, my fishing rod microphone, and you can ask your questions. So for now, well, my name is Fido Albers. I work for RDM Next, and we're doing this event together with Rotterdam AI. And to explain something about what Rotterdam AI is and what they do, I'm gonna give the mic to Maria. So.
Am I gonna have to click it, or are you gonna click? All right. This one, oh, left and right. Okay, cool. Also, I have to stand right here, right here. All right. Welcome everybody. We have been planning this meetup since March, so it's here already, and we are so happy. Thank you to the RDM Next for collaborating with Rotterdam.ai to bring you this meetup in AI in maritime and aviation. So who am I? Let me just tell you a little bit about myself. My name is Maria Bahamam. Some people raised questions about where I'm from. So I'm half Middle Eastern and half Indian. And I have a background in computer science information system. And I am the chairwoman of Rotterdam.ai. I spend my time doing these three things, but it's not happening. These companies, I run these three companies, New Mastermind, which is a full-on digital marketing agency, and Madame Rotterdam, which is a marketing platform for the city of Rotterdam, and of course, Rotterdam.ai. So what is Rotterdam.ai? Pretty much is enabling people to apply artificial intelligence, and most importantly is our mission, which is democratization of artificial intelligence, meaning that everybody is welcome into our community. It doesn't matter what's your gender, what's your background, whether you know how to code or not, you're welcome to join us. So our community, as you all know, artificial intelligence is all about technology, but we're all about people, and we really, really want to teach people how to actually get access to the tools and then the knowledge, and then to apply artificial intelligence in business. So we really want to help everyday people to start their own startups or learn it or to further their own career. And we do that by focusing on three main things. The first one is quarterly meetups, pre-corona, of course. After the corona, I think it's going to be one meetup a year. And then we do ecosystem mapping, which is whom and what are the most important elements in this ecosystem of artificial intelligence within the Netherlands, and then education. But why education? If you can see here, it says 40% of executives are applying training and education within their own enterprises to learn the application of AI in business. So they are using it to further their own business, while 26% of executives wanna apply education of how to learn the technical part of it in their enterprise. And I think that this is like 56%. And I think the remaining, they won't be even here. I think they're gonna get bankrupt if they don't do anything with it. So mainly we do meetups and boot camps. We have carried out 2 boot camps so far, and we thought that the majority of the people who go into enroll going to have a technical background. But the funny part, the majority of them have marketing background with zero knowledge of coding. But they came in because they wanted to either have another career path, or some of them want to understand a little bit more of it. Oh wow, the picture changed. No, I don't, I don't know why. I don't know where am I in. Okay, sorry for that. And so we have more than 10 startups graduated our boot camps. We've done that through money out of our own pockets. So what we need for our boot camps is funding and a location, and maybe creative solution to go around the pandemic rules. So if you have a creative idea besides online and maybe a bigger space with people sitting like this. And the second thing, for our meetup like this one, we collaborated with RDM Next. So if you're open for a collaboration, please come to me. As of now, it's a one-woman show. I'm the chairwoman of this nonprofit organization. By the way, it's a nonprofit organization. So if you have time, it's not paid. So if you have time and you're willing to further your or open another door for you, please join me. That can be you. You can be our financier. So if you're smart with math or smart with numbers, we need you, or a secretary. Get in touch with me. This is my personal email, so please no spamming, please. And I will end with this. A year spent in artificial intelligence is enough to make one believe in God. So I'm going to convert you to artificial intelligence. Thank you. That's my time. Now I will introduce Captain Kees Kruisheer. Right? Give him a hand, people.
All right. Thank you very much. All right, people. Good evening. My name is Cornelis Kruisheer, in Dutch, Kees Kruisheer, if we go in English. And I'm actually a strange duck in this harbor because I'm not from shipping, nor from artificial, and maybe also not from intelligence. But I'm from aviation. I have spent my life flying airplanes. I started in the late 60s with small airplanes and ended up as captain and instructor on the third generation automatic airplanes flying around now. Not even the latest one, but close enough. Um, I like to talk a little bit about the automation because it's one of those issues which are heavily addressed in this group of people. Automated ships, autonomous ships even, and the link between aviation and shipping. If we go a little bit in the link of shipping, then we see on this slide a little bit how aircraft tended to look like. And there's one ship in the middle, and it's the most simple one. The base of aviation is in shipping. When I went to school, when I went to flight school, we had to learn navigation. We had to learn to work with the maps like Polar Stereographic, Lambert maps, Mercator maps. We had to plot courses, all based on what principles were of navigation of shipping. Meteorology came straight from there. Even the air law came straight from the shipping. If we would land with an infectious coronavirus 19 passenger on board, we had to put a flag out of the window, straight from the shipping. No change there. If we look at the airplane on the right-hand side on the screen, you can see that there is quite a difference between the airplane, and we talk about the same time as the left-hand screen, which is a ship. The airplane on the right-hand side is the old technology with a lot of buttons and a lot of switches, and the pilot has to handle them all. He didn't need to do everything himself. He had, for running his engines, he had a flight engineer, also like in the shipping. The ship engineer. For a navigator, he might have had a navigator as well. If we look at a modern airplane, a few screens, which you now also see on board of ships, and a few switches to control the engine and power output, and some computers to control navigation, and some switches for controlling the radios. And we can run this airplane fully automatic for up to 10, 12, 14, 16 hours with actually no interference. It will even land itself if necessary. In the past, we had, and that's the way I learned to fly, we had a compass, little thingy with liquid filled in front of your face. You still have that in ships, I saw. We had RPM and oil pressure, and if that was okay, you could look outside, we had a perfect flight. Of course, that doesn't work anymore. We, I still think that in shipping, if I've seen on board the ships, the principle of compass heading, RPM and oil pressure is still doing the job. But aviation have evolved quite a lot away from it. We needed to automate. We needed to find a solution for the development within aviation. And that was driven by actually three items. First was we had higher speeds because of the jet engines. On board of we went up to speeds of 1,000 kilometers an hour, depending on conditions, of course, outside. And we flew higher altitudes because jet engines are very efficient at high altitude. And that means that navigation became a problem, and we had to automate navigation. In the past, we would cross the Atlantic on a 4-engined propeller-driven aircraft, and we would have a navigator with a sextant or octant who would plot courses and position for us. And that was not possible anymore because of the high speeds, and we are flying above the weather. The first navigational aids came by non-directional beacons. We could receive beacons, we could plot direction to a beacon, we could make intersection, and we would know our position. But if you go with 1,000 kilometers per hour, it's not very accurate. You have a big triangle where you can be. Then became satellite navigation, of course, GPS navigation, which makes a lot of a difference. All navigation nowadays on airports, on aircraft is automated. We have a map display. We have the aircraft routing is plot on there. We know exactly our position, our speed, our altitude. So we needed to use this information to drive also our autopilot system. Autopilot system in the past was a push button which kept the wings level, and you had to turn a little button to make a little bit of bank and then put it back again in order to fly around. Nowadays, everything is integrated. All is integrated. We have on the next slide, I guess, yeah, we have the radio navigation, the third moving factor. What is the same in shipping and aviation? It is the same. But the high integration in shipping is not as much developed as it is in aviation. In aviation, it's highly developed. And that meant that we had to change attitudes. We had to change perspectives. We had to change our training. We had to change our management systems. We had to change our safety management systems, all to accommodate the effects of implementation of automation. And that was a tremendous job because when we started automation, we had quite a few accidents by mishandling the automation itself, but also our crew concept, our what we call crew management principles, were not based on dealing with a crew who is supervising what the aircraft is doing, not steering anymore. It's management. Modern aviation is 95% management and 5% flying with the seat pants. So we had to change this. That gave problems. The change of automation gave problems. First of all, because rightfully, they saw that less people could do the job. And I have to think about Rotterdam in this case. This is the famous crane elevator, number 19. You can find it in the Maritime Museum. It's still there, which gave a revolution. It gave a strike in Rotterdam in 1907 because all ships in the past were offloaded by sack carriers. Hundreds of people going into the ships carrying the sacks out of the, I have to put myself in the screen as well, carrying the sacks into other ships. Then there was a guy who saw his, it was in the time they invented the vacuum cleaner, saw his wife or his mother vacuum the house. He said, oh, that's it. So he built a big vacuum cleaner, which could empty the ship in a few hours with maybe 6, 7 men into smaller ships, which were parked on the, or moored on the other side of the ship. That was a revolution. That was automation driven by steam engines. And they have been working until even the 70s or the 80s, I think. Actually, what happened is the people were afraid of losing jobs opportunities. It didn't happen. It made the Rotterdam harbor grow because they could handle more ships, they could handle bigger ships, and they could load from one ship in the other ship in more efficient way. It is a form of automation. Not artificial, not very intelligent, but it worked. But it gave reason for striking. People wanted to stop this development because they were actually afraid of losing their jobs. It was the same in aviation. When automation started, we had big problems. And of course, the first victims in aviation were, in this case, the navigator. You see here a Navy navigator who is on altitude using a sextant, which was built sticking out on top of the airplane to shoot stars or suns in order to, I don't know how that worked, I never learned that one, to put the position in place. Yeah? Of course, the second one was the guy who had this console in front of him, the flight engineer. The flight engineer did everything from setting the RPMs to setting the temperatures to everything. Even in takeoff, the flight engineer would bend over to set the power for the flight crew, for the captain. And then the captain would take over. You only need 2 or 3 switches nowadays for this. Everything is automated. All the computer systems pick up the signals, they send it to a central processing unit. Central processing unit senses outside air temperature, speed, pressure, altitude, and would then regulate the engine automatically to the power setting required for that phase of the flight. The only thing what the captain nowadays, the pilot, is auto thrust on, and after takeoff, autopilot on, and then he will sit with his hands, study all the instruments, which is a little bit of a change of flying an airplane. And maybe this is the last victim of the automation. Maybe we don't need a pilot anymore. Maybe we go full autonomous at a certain stage. And that is technically possible. The reason why it is being delayed or not done is man, human, and concerns of safety related to that. But we solve those problems. We can solve those problems. And I foresee in the future that probably for passenger flight there will not be so much as autonomous flight, but for freighters, why not? You can have fixed routes, fixed freighter airports flying from A to B without a crew, and it can be safe. It can be. So maybe the guy's out. How do we do that in shipping? We need to improve on the automation in shipping. It's not very much integrated yet. The question is, will there be job redundancies? Well, maybe the public will ask me this question. Can we go to fully automated shipping, like my son is doing with Captain AI, autonomous ships? Where can we use them? How can we use them? But we have to look at the first steps of automation. We have to go to a growing process where we go from active, involved in steering a ship to pushing a button at the start of the trip and switching it off when we have moored on the other side of the ocean. It is possible. and it is possible safely. But we need to look at the developments in that area. There are some problems with it. We human and automation are not working properly together. We can't deal with automation. Yeah, we can do our computer. We love our iPads, we love our stuff, but we can really automated processes, we are not good at it. That's one side. We have to learn to manage processes. We have to learn to look at safety factors in the processes, redundancies, with another pair of glasses. Not the one who is sailing the ship, but the one who initiated the processes, monitoring the processes. And then the problem will rise when systems are failing, because we lost the touch to deal with the system manually. A big problem. We found in aviation, of course. What does good automation do? It reduces workload. You have time to do more complex things because part of it is automated. But poor automation is reducing situational awareness. Automation processes, we are falling asleep behind the screen. Actually, after a while, we don't know where we are, in which part of the process we are. So it has a negative issue we have to solve as well. Lack of practice, we talked about it. We don't know the manual skills anymore, and we do not understand the automation processes when they failed or partly fail. And I've seen it on board, that you sit behind and in the cockpit doing a check, and a little bit less experienced pilots, automation sort of disconnects, and he will ask, what the hell is it doing now again? Because he did not understand the processes properly, and the automation actually disconnected because mismanagement of the automation. We have to review all this. We have to train people to deal with automation in a different way than we are used to train people to deal with equipment, with ships, with airplanes. Automation dependency. At a certain stage, and we see it now more and more in the aviation industry, is that we are so depending on automation that we are actually trying to solve the failures of the automation system before we are going to get rid of the automation and do the manual flying, which is a bit of a bother. And then the last one, that is complacency. We are so used to automation that we just push the button and maybe go to sleep. And that's also not the way it is, because there's not much more to do. We have to monitor it all the time, hours and hours at a go. Maybe we should go full autonomous. The question then pops up, can we fully automate navigation on shipping? Fully automate. Integrate it in everything, from power settings of engines to course settings to correcting for seawater temperatures, etc., etc. Can we automate the engine control? Can we integrate it all? How far are we in that automation? Not question of RPM and a digital signal to the engine. No, optimize it, make it run more. And how do we deal with other traffic? One of the issues in aviation, proximate traffic. How do we deal with it? How do we recognize it? How do we avoid hitting each other? So there's a lot of things to develop before we are there. And I have the feeling that in shipping that is ran a little bit behind. And I think there is a good opportunities to do something about it and make it more efficient. When we deal with automation, we have to also to deal with the human, I will keep this short, human-machine interface. We have to redesign the ships. We have to redesign the controls of the ships. We have to redesign almost everything, like we did in airplanes, in order to make it work for us. and not the other way around. In any case, I don't want to go any further. My time is up a little bit, but I would like to answer some questions if there are questions in here concerning this subject or online.
Yes, I'm on my way.
How far along are we? And what is one thing you think it shouldn't be automated in the aviation?
Ah, I think if you mean in shipping or in aviation, I think it will be very difficult to convince the public for automated airplanes as long as we transport passengers. So I think that will take some time. We are quite far evolved in this automation. We don't have to do a lot of stuff on board of the airplane, but I think the possibility for automation with fixed routes, with fixed airports, is more in cargo flying, where you actually can send, well, where you can send one airplane from A to B, from one parking position to another parking position, without involvement of human beings. But we are not there yet, although the technology is there. The technology is available. Yeah.
Yeah, hello, Kees. Thanks for the story. I was still wondering, let's say we live in a future where all aviation is automated, like autonomous from A to B. Do we still have to train pilots, new pilots? Because I think the knowledge of flying a plane will dissolve if we have, let's say, a decade of autonomous flying. And isn't it, wouldn't it be for nothing if we train pilots and they would never have to be flying?
I think there will be always a need for pilots, but not anymore in the automated. If we go fully autonomous, which I don't believe it will happen soon, that there will be not much pilots involved. But what we will have is the people who monitor the systems, who can control remote monitoring that everything is working fine. So there will be aviation trained people as well, who can even maybe interfere in the operation at a distance. But airline flying is not the only flying there is. There is commuter flying, there is business flying, business aviation, there is crop spraying, there is all this kind of other. There will be need for real pilots as well. But I foresee that maybe in the future, I must be careful, that the function of the pilot will be taken over for someone on a center who is monitoring flights on a distance. And that will not go away. That will not go away. Yeah, maybe with someone who is specially trained in air traffic control, in aircraft equipment, technologies, etc., etc. Yeah.
All right. Like what you just said, also involved full autonomy. And there's one online participant who's asking a question: how can we trust full automation? There's a lot of scenarios a plane that can be in. So there's always a possibility that the plane will be in a situation he did not expect. So
yeah.
How do you deal with that?
Yeah, that is actually the root of the problems within automation. If you look at the older generation of pilots, and I talk maybe my generation, I'm not the youngest here, we didn't learn to fly with autopilots. It took for me a change in character, a change in insight, and a change in trust to trust the automation. The trust is built on experience, on keeping overview and insight of the processes of automation, and improvement, day-to-day improvement. In the past, automation, we did not rely on it. So let's say that we had a failure, an engine, loss of an engine power after takeoff. We would switch off the automation. We will not use it. We will go to full manual flying. And that is contradictory to the principle of automation, which is to reduce the workload. So we're going to increase the workload. Now automation is so reliable that if you have a problem after takeoff on an engine, you switch on the automation in order to reduce the workload. So it's a growing process which based on the trust and the reliability of the automation itself. It will grow. It will grow. And yeah, things can fail, but I think we are able to control those failures by redundancy as well, mainly. Yeah.
So more redundancy,
Sorry?
more redundancy.
Yeah, you have at least 3 autopilot computers on board of an airplane. Where 2 work together and 1 is a bit on standby.
More questions.
So what do we do if this autonomous plane gets hacked by someone?
Oops. I hope it will not happen. It's a weak factor. I agree with that. I've not really prepared for an answer for that question. I find it a very good question. It happened already. It's happening already. That they try to break in one way or another in computers of airplanes. I don't have an answer for it, but I hope that technology is going to be evolved with the involvement of the computer systems that will not be possible. Maybe it is to contain to full automation, that you do not interface with the outside world. Yeah.
Let me repeat that. Maybe the AI understands that something is
That's
wrong.
not my specialty, but I do believe that there are. Yeah. Yeah. I agree. It's a difficult, it's a touchy subject.
Well, I came from Russia, but I'm not a hacker. Actually, I've spent 10 years working at sea as a CFR, as a navigator.
Yeah.
So what all you said is quite clear for me and concise because I've been worked for a long of time on that. The question is simple. Like all of us has a driving license if you need to drive a car. The same as of a navigator should obey the rules.
Yeah.
Colrec 72. Maybe you know this. Collision regulations, which has been issued in 1972. The problem is that for these regulations, it's difficult to manage simply even for the navigator because some rules and regulations a little bit unclear. Yeah, because you have to interpret it in a different way. Is it possible to insert and transform these rules and regulations to the computer, which will be operate the vessel? And who will pay for that in case it will be a mistake from them?
You mean that the regulations are applied in the computer system?
I mean the regulations which normally use now at sea, between the vessel, how to avoid collisions between the vessels.
Yeah.
The problems for this regulation that they are really unclear in 2020, and it's still really difficult to define a special code or algorithm which computers which can be established on the vessel can be followed.
I think myself can give an answer on that one, but let me give you a quick opinion about this. What I found out is that, look, in aviation, every aircraft communicates with the other aircraft in flight when they are in proximity. And that's done by transponders. Transponders keep each other informed about the position of each aircraft around you. And if we get in too close proximity, we have a system called TCAS, Traffic Collision and Avoidance System, is one name for it. And it will automatically nowadays change the altitude, not the course, but the altitude of the aircraft. And they will communicate with each other. So if one aircraft starts descending because there's an impending collision, the other one can start climbing. And it can even communicate with 3 or 4 or 5 or more aircraft at the same time, because that is possible close to an airport. What I'm not sure about it, and it's my question to you, do ships have also this kind of systems where they communicate each position to each other? And I don't mean radar. I mean transponder system.
There is only one system named a automation identification system. I think it works also on the aircraft as well. It's not a navigational system. It's only for familiarization. What is the vessel? What is IMO number, MMSI, etc., etc. But when it comes to navigation, it's not related at all.
So maybe one of the things that should be developed is that you have this proximity communication. Luckily, we don't talk about very high speeds. What is a ship sailing average? 35 knots? 30 knots?
Yeah.
The only difference is that he's actually actuating. So AIS and aircrafts both broadcast their position.
Yeah.
But the difference is that in aircrafts, the autopilot has direct control to say what to do with that information. Whereas in crafts, that's not the case. You just see it on a screen. Yeah.
So improvement, yeah, I think this system could be very well used to build a safety system around avoiding of collision. Yeah, should be.
Really difficult to find the proper solution about how to avoid collision between the vessels. The shipping industry, is quite conservative. I'm not sure that it would be possible in 10 years to replace the people and
Yeah, but
person. Okay.
I think my son is in dealing with that at the moment.
Maybe that's a good idea to move on to the next speaker indeed.
All right.
But first, let's give a warm applause to Kees.
Thank you.
And I think we'll be back afterwards to ask a few more questions if you have that, because like we're halfway through the subject. Maybe you can start switching the mic with Gerard.
Yep.
And then I'm gonna ask Gerard already a question for the next talk, because what I'm wondering about, like for now, like when you hear Kees talking like this, is there something you would consider to take on in your work, to take with you? Like, are there lessons you can already take from what Kees has said so far, or should we elaborate on that subject a bit more later? But first of all, let me properly announce you, ladies and gentlemen, Gerard Kruisheer.
Right. All right, nice to meet you, and I'm really excited about this talk. It's the first talk I'm doing with my father, but I'm more excited about this because I think that having my father and seeing, he's also an auditor, so he really knows the industry really well, and having grown up in that world of like of how these big crafts become used, also opened my eyes to a lot of these things. So there's a lot of questions that are relevant, and I'm excited that you guys are already asking these questions. And these are things that like it's my full-time job to think about. And I've also talked to my dad various times about the different ways, like how do they solve this problem with aircrafts? How do they deal with this situation? Because it's a lot different from cars and autonomous cars in that you actually there's various levels where it's different. So first of all, you're working in a really dynamic system. So both the air and the water are constantly dynamic, right? So when you hit the brakes in the airplane, you fall and crash. When you hit the brakes in a boat, you keep drifting, right? So you actually need to build a sophisticated system to take this into account. Whereas with a car, the physics is a lot more intuitive, and I think the infrastructure also takes a lot of those things into consideration. The sensor suites on aircrafts and boats are also a lot more similar. We have radars. We use a lot of more complex algorithms. So there's a little bit of borrowing from that I think is really interesting. But let's touch that subject again after my presentation. But let me start my presentation off a little bit different this time. So I want to kind of have just a few ideas of what people think the future of a port would look like. Like if we traveled into the future, much like you see in movies, what do you imagine a port would look like? So that's essentially, it's a very simple question, and I think these questions have been asked in in the past. Like, okay, what would it look like if we had to send someone into space, right? And then you get the sci-fi illustrations of a guy making a bullet, and he's like, okay, I think it would look like a bullet, and the bullet would have to go, at high velocities. And essentially, there's some truth element to that, right? The what is today the rocket, which brings people into space, is kind of like a bullet. So I think in that, even though it's very broad and very vague, I think there's elements of truth that you can see because we inherently know some principles, right? And so when I ask you that question, what does the future of ports look like? I'm thinking it's got to be more efficient. And that's really what it is. Like if you take technology, like we've seen it since we were a kid, we've had little, we I don't know if you guys grew up with phones, but at the age of, I don't remember how old I was, maybe 14 or something, or younger, I got a cell phone, and then seeing that whole development roll out, I never imagined it would go so far, right? So like that is a function of making technology better. And the other things that we see is like, okay, if I want to order a package from Amazon, right? I just log into a website, I click what I want. I don't even have to go to a shop anymore. Like, did you ever imagine that that's the world that we would be living in, right? Where you could just hail, essentially, just get a package just by picking pictures on a screen, right? It's a little bit ridiculous when you think about it that way. But essentially, if you want to bet on the future, you kind of have to bet on these things, right? You have to bet on these things and you have to be right. And so our bet at Captain AI is that autonomous shipping is actually the way that technology is going to go. If you maximize the efficiency of logistics, if you maximize the efficiency of how a ship works, if you just keep those developments going and you just imagine that all of that's going to get better, what do we get? Well, we get autonomous shipping, but essentially what you get is an optimal logistics solution. And that's essentially what we are. Captain AI is a logistics company. We do autonomous shipping, we do engineering, we do a lot of things, but we solve a logistical problem. We get boats from one point to another a lot easier, safer, faster, more efficient. Okay. Oh, here. All right. So this is a little bit what I see. So we have a cloud element to it. You can see that you'll be able to access information about a boat anywhere. You could plan a trip from anywhere, and then you'll have all the data from all the ships to be able to give you better, more informed decisions. And that goes hand in hand with planning. And then eventually we'll be able to do control. So like what you see with aircrafts, right? We have the broadcasting of positions from boat to boat, but in aircrafts, they say, hey, that ship, that airplane is traveling in the same air level, so one of us needs to go down. And the computer decides, not the human, because you're talking about sensors. And then once there's too many peripherals, can a human really take that all into consideration? Okay, so that's the promise. It's increased safety. So if you make things more efficient, you're going to be increasing safety because it simplifies the process. You're going to reduce CO2 costs because essentially you're taking very optimal routes. I can anticipate where a boat is going to be kilometers ahead. I can't see kilometers away, but I have a radar, and I can process that radar information to make these choices. And then just the whole port call optimization. That's just connecting the dots. So when a ship arrives, you need to know where the payloads are going to go. You just want to have a high level schedule of what's going on, where things are going. So the analogy that we give is that You have to think of the whole world like a big warehouse, right? You have packages moving from one part of a warehouse to another part of the warehouse. And right now, that's being done by humans, right? So if someone falls, hurts themselves, they can only walk so fast. There's a lot of limitations. Humans are great at improvising, at doing things that requires creativity. But getting a package from one part of the warehouse to another, is more about agility. It's more about scheduling. It's more about planning, and it's more about coordinating. And the more you do that, the better you'll be at getting those packages from one point to another. So this is a little bit how it looks like right now. So what we do, so last month we did a demonstration with Kotug. We made a path, we dispatched that path, and then we actually had the boat sail that path. And that's a little bit connecting the dots, right? So you have a person that says, okay, I need to deliver, or there's a boat arriving that we need to attend to at this location, and you need to be there at this time. So the planner, all he has to do is log into our website, draw the plan, and then they can dispatch it. And then simply the boat gets a message, the captain chooses to accept it, and then the controls will start going until it reaches its destination. Okay, so it's not really too much different from what's currently the situation. You have a planner, you have a way that you're going to sail, and then the captain gets the message, and then they dispatch it. It's just a little bit more efficient so far. Okay, and then of course, we're trying a lot of these different things out. We want to know how fast a boat can go, how close can boats go, what happens when there's a man overboard, what happens if there's a lot of these conditions, how much can we push the bounds? And so that cannot be tested in the real world. And those kind of tests you want to limit. And for that reason, we're also using a simulator. And lucky for us, one of our investors, VStep, develops these simulators, which actually also uses physics. It's not only good looking and it looks really realistic, it actually also takes into consideration physics, and the way that we actually plug into that boat is exactly the same that we plug into a real boat. So when we send the commands to the autopilot or to the different control systems, we're sending the same instructions that we would be in the sim. And then the sim, of course, has a model and models the environment. So it models how the boat behaves and interacts with the water. And then we say, okay, well, can this boat actually do this? And if the boat can do it in the sim, then we test it in the real world. And that's part of the process that we use to develop this technology a lot faster. All right, I worked on these GIFs quite a bit, so I wanted to put both of them in there. Couldn't decide which one I wanted. So these are the two projects, or two of the projects that we're working on. So it's the water taxi that you see here, and then the one that was previous is the RPA3, yeah, which is the one that we're working with the Port of Rotterdam for the people that are from the Port of Rotterdam here. That one. Okay. So this is a little bit how the whole thing looks like. So you could even have a third-party company that has some software that they use for scheduling. They insert the time that they want the boat to arrive, insert all the peripherals of boat type and things like that. And then simply what it does is it dispatches it. And then once it arrives, the captain gets this message. And if he agrees with the actual trajectory, he accepts it, the autopilot switches on, and you see it going. So in March, more or less when this talk was going to be planned, and then Corona happened, this is where we were at. We wanted to do this in the real world, but we couldn't, so we did this in the simulator. And then a few weeks ago, we actually managed to do this in the real world, so that's kind of cool. And this is the video of it happening in the real world. So you got the planning, and then the RT Borkum, and then here you see the captain, he accepts the route, and then off the boat goes. So what can you do now? Now that you have a very clear path of how the boat is going to go, you can actually share that information. right? If all the vessels were saying what routes they were taking, then there's a very clear intent between all boats of how they're behaving. And then you can start avoiding ships. Then you can get into that situation that there's a collision avoidance situation. And you can start classifying situations. And then you can say, okay, in this situation, this is what call regs determines is the right scenario to play out. And then that has to that gets tested and that gets implemented. So this is just one small thing that once you build one feature, you can just kind of say, hey, well, all of this is also possible, but that would never be possible if you don't build the first feature. And in this case, we built one feature to generate routes, and now we share that with everyone, and everyone can see each other's routes. And there's so much that can come out of that. Yeah. So how do we do this in the real world? So what is the engineering behind it for those of you guys who are a little bit interested to see what's under the hood? Well, our sensor suite right now consists of cameras. We do just basic bounding box detection. We haven't gone too fancy there yet, but we can actually leverage the bounding box detection quite well because with cameras, you can detect where a boat is at a lot higher frequency than you can with radar and than you can with AIS. So that can give you a real-time update on the position of where a vessel is. This is AIS. So this is something that we've mentioned before, but I guess we never really kind of clarified what that is. And what that is essentially it's the broadcasting of your position. So if all your cars were broadcasting their position, you'd be able to see exactly where they are. And this is the kind of data that companies like Tesla would dream to have, right? And for the maritime industry, we've had this kind of data for years. I can actually pull up years and records of AIS data and say, hey, this is how cars behaved in the past. And or this is how boats behaved in the past. And if these other companies could do that too, then they would actually maybe change the approach in how they're implementing autonomy. And the way we use this is to solve exactly that problem, call regs. How do you generate a route that is compliant with call regs? And so for you guys who don't know what call regs is, it's, let's say, the rules of the road in the maritime. So you have to stay on the right side of the water. There's so many rules. And the funny thing about the maritime industry is that they always get broken. It's like you just call in a VTS operator and say, hey, I want to cut this corner. And that's actually standard operating procedure. So how do you capture all of this behavior? And that's where we actually differ from other companies. We've extensively looked at different companies that are doing routing solutions, and none of them actually checked all the boxes. So we took the job ourselves and we created our own routing solution. We pumped in historical data of boats and how they've behaved in the past, and managed to get actual realistic paths out of it, of how people will behave using AI. So a lot of it is looking at popularity of routes. And of course, at this point, we can sail on them, but the captain still has to consent. Okay, and then this is radar. So what you see here is Atlantis, and that's our visualizer. So right now, I'm joking with my colleagues, you have something called the ECDIS display on boats, and dare I say, we call this the Nexus display, or I do. Because I do think that the ECDIS displays as it is right now is a 2D platform which doesn't really show the depth of data that you need. Once you start integrating a lot of different peripherals, you need to have 3D. And I think that goes without saying, but future ECDIS displays will have to take another level of dimensions if they're going to consider bottom bathymetry and if they're going to take top topography into account.
I have a question from online about the AIS system, and the question is, my guess is that there are a lot more recreational vessels compared to non-recreational vessels. How do you tackle this?
Yeah.
Like, do they all have an AIS system?
Yeah. So this is actually really important. You cannot sail on AIS alone. We have seen it too many times that we're on a boat and that we're actually sailing by, and that on our display there is an invisible boat. And if it wasn't for the object detection for the cameras, and for the radar, you would not be able to see that boat. And so what we're actually implementing, and I didn't make this part of the talk, is something called sensor fusion. And sensor fusion is something that you use to gain a confidence about your environment. So the analogy that I usually give is I don't use a duck, I use a dog. But if it smells like a dog, if it, you know, if it barks like a dog, and if it looks like a dog, it's probably a dog, right? And you have all three sensors of yourself that confirm that there is a dog. So if AIS doesn't say that there's a boat, you need to have another sensor that it can work when AIS is not working. And for us, we're using cameras and radar to deal with that situation. And that's how we're going to deal with all of the pleasure boats and all of the anomalies in AIS. And ironically, the issue with AIS is that it's dependent on human input. So if the captain actually doesn't switch on the way using engine, we get a problem because it's not automated. So I thought that was a little bit ironic. Yeah. All right. All right, so that's the sensor suite. And then this is some of the projects that we're hoping to be the first in. We hope to have the first patrol vessel. We're working on that with Port of Rotterdam on the floating lab project. What's really interesting about this vessel is more of the sensor input. So we're testing radar, camera, and AIS and the fusion of those in determining how a boat should behave. We're also, of course, working on the water taxi. This is a smaller, faster vessel. In some ways, a lot more like a car than it would be a boat. Doesn't use all typical maritime equipment. And it has some interesting challenges. So like we're not allowed to mount stuff on the top of it. So that gives us an opportunity to try machine vision and to try smaller profile sensors to be able to accomplish the same task. And then of course the Borkum, which is an incredible boat. If any boat is designed to be autonomous, it'd probably be this one. And the reason is because this one actually has 3 rotors at the bottom. So you literally have 3 motors and they're all can turn in any orientation. But a human only has 2 arms. So how are you supposed to coordinate all 3 rotors at the same time? So typically a captain would actually cheat. And what they would do is that they will set 2 engines in good steering mode, or they would treat the back engine as a rudder. If we can optimize the level of control to such a point, we would easily be able to do maneuvers that humans can't do. So this is one of the reasons why I'm really excited about this boat. Not to mention that it's also a showpiece and it's beautiful and it's got leather interior and it's like less of a boat than it is a yacht. Okay, so this is really the concept. This is the master plan. You have different fleet owners in a port, and they all have their own businesses. You know, water taxi needs to commute from one point to another. You have surveyors who need to go around and make sure that everything is going well and to be there if things go bad. You got tugging situations, and all of them can benefit in different ways from this improvement in logistics. This improvement in being able to do a maneuver as a tugging operator that you would not be able to do without some level of autonomy. And also, the interesting thing is you could actually start making new business cases. Once we have enough people that are connected, we'll be able to plan things a little bit better. We'll be able to automate processes, and we'll be able to do things that was before not possible. It just so happens that the technology that we're using to automate ships can be used for remote surveying. We are experts at seeing what ships are doing. We know what all the information is going on a ship. We can broadcast that information out. Now, wouldn't it be really cool if I could also do inspections? I'll use the same camera that I'm using for object detection. I just look at the history of those bounding boxes and what it detected in what location. And now I've done an inspection for free. So that's just by the way, you know, and that's what I'm really arguing is that once you start integrating autonomy, you're going to be finding a lot of business cases that will pop up because we're fundamentally changing things. So this is a little bit like the case with the surveying. How would it look like? What's the next generation surveying? Well, it turns out that if you are surveying and you're trying to do a scan of the bottom, which you need to do quite frequently, you actually have a side scan sonar or multi-beam or something like that. The captain actually needs to be very experienced because he needs to sail in a very specific way to make sure that those scans are actually done well. And if he doesn't do that, then it's very expensive to get that wrong. You have to get that right. So wouldn't it be nice that if we can also see the bottom and we have access to the controls and those things are connected, that we can actually slow down the boat while it's turning at the right rate to make sure that those scans are beautiful and actually indicative of what's underneath. So this is a little bit of an example of what it would look like. So you have a boat and the boat just happens to have a sonar and anyone can now have access to that. So that's also an interesting idea. If you want to give out your sonar data, you could, and it'd be really interesting for other boats in the fleet to know how deep the boat is, how deep the bottom is, because the bottom bathymetry changes quite a bit. And if they can share that kind of information, it's actually safety information that they're sharing. That would be really nice. And then, okay, also with water taxis have a really interesting problem, which is they need to be able to route and get boats from one point to another. So that's where maybe knowing how long it takes to get to a point and what kind of route you're going to take is interesting. When you have your Uber and you hail your Uber, don't you see when the boat's gonna or when the car is gonna arrive, or when you're ordering in Taj Resort, you know exactly, oh, the guy is 2 minutes away or he already left and he's almost home. That's really nice. Wouldn't that be nice if you could just open up your phone and say, okay, it's about 5 minutes until my water taxi's there, you know, because it gives me time to go down to the store, grab a quick soda or coffee, and then head off in the boat. So that's also a good opportunity for us. And then, of course, port operations. There's a lot that can be done there. So we study a lot the behavior of ships. We look at how boats make choices, what is the right way to do certain things. And then we also have we're working on a very sophisticated way to kind of monitor all of the ships. So each boat has a radar, AIS, and a camera. If I could fuse that information with our sensor fusion algorithm, upload that into the cloud, and other ships do that, then we would have a very realistic view of the whole port. And that's essentially would give you levels of detail and timing that you could use for scheduling and for assessing that you wouldn't be able to do. I'm talking about like real-time positional situational awareness of all ships. And it's not crazy. It's actually, it's just a choice. Do you want it or do you not want it, right? Okay. And then the future of tugging operations, I think there's a lot to be said there. Like I mentioned before, we have the vessels that actually can do complex maneuvers, and I'm really curious to see with our collaboration with Code Tug now that we've announced that how that's going to play out, what other benefits we can bring in, and see how that all gets rolled out. So essentially, that's kind of our vision is to actually, right now, we optimize. We help you with planning. We say, okay, we know where you're going. We know what is going on. We will share that information. If you want to plan, you can use our API. Next year, we'll start working on a kit, which is to actually give that shift between planning and awareness, and also be able to control the actual vessel. So how do we go to just actuating from responding to the environment? And then finally, hopefully, we can have broad adoption and world dominance, that kind of stuff. So it's a big project. It's a big vision, but I believe in it. Like I said in the beginning of the presentation, I mean, if you could just see the future and bet on the right game, right, then it's an obvious choice. You know, like I think I meet too many people saying, "Hey, yeah, I thought that would succeed in the past," and then it does, but you didn't place your bets, right? So I really think that Captain AI is on the right path. We're not solving just actuation problems. We're not solving, you know, boats avoiding other ships. We're solving a logistical problem. We're actually optimizing a whole port, and we're trying to make the whole system work smoothly and integrated. And I have a lot of answers that I wish I had now changed my presentation to talk more about prediction and how we do object avoidance and stuff like that. But I can talk about that now that this is the last slide. All right, so um, questions?
Maybe first of all, a big round of applause for Gerard.
You talk a lot about efficiency and it being smart, but I'm really curious about what is this for the human experience? Because you gave an example of the Amazon warehouse. Well, to many people, this is hell on earth.
Yeah.
Rich people only have to do what the app tells.
Yeah.
The app literally tells every step they have to follow.
Yeah.
All skill and autonomy is taken away from them.
Yeah.
So are people in the port going to become slaves of the machine that are simply dictated by your smart AI, which is super efficient, which saves money, but we, to port workers, they don't give a damn that somebody else is saving money. Their autonomy, their pride in what they do, their skills are taken away from them.
Yeah.
And they are just only watching at a screen that's telling them exactly what to do, when, where, and how. If they don't do it quick enough, they'll get less pay, or I don't know, they'll
yeah, the whole Amazon
So I'm
deduce
curious
their pay
how,
if
how
they
you
don't.
think about that, because
I think working in a warehouse was never exciting to begin with. No offense. So the going from not using an app to going to using an app, I don't know if that really is like that big of a deal. But I do understand what you're saying. You're saying like we will become like essentially a slave to what the advice is, and then it kind of gets boring because it's like, okay, well, you're just supervising. Um, I think that is in the short term a concern. I think that is a valid concern, but I also think that there's more to it. How many people do you have that are working and studying and spending tuition fees on studying AI, on learning how to make algorithms better, who want the opportunity to create a future where, you know, ships can go to Mars even, right? There's a whole new workforce being generated and whole new capital system working. And what about these guys, right? There's a tendency for us to have nostalgia about the past. There's a tendency for us to know that in the past, things worked really well and I want it to stay that way. But the world is changing, and it's always changing. And I'm sorry to say, but it's just the way it is. And I don't say that in a bad way, but I say that in the best way, to be honest. Because if things don't change, if things don't get better, you'll be living in a very static world. And that does not sound exciting to me.
you say things get better. To many people, they're not getting better. An Uber driver is, I don't think they experience that as a better life than the taxi drivers we had 20, 30 years ago. So I'm really wondering if the people that are on a ship, that are proud of their skills, they're happy what they do, and in the future they become like an Uber driver, I don't wonder if that's a better life. It saves money, but I don't know if it's a better life.
Well, the cost incentive idea is like, okay, are we just going to do things because they are, you know, better cost for value, right? I get that. Um, but there's a reason why we always reduce costs also, right? If one person can handle a bigger ship, then that means that the port can actually dispatch more complex operations. That means that the port actually gets more value. That means that business comes in a different way, much like my father showed with the sack carriers, right? There was a huge protest about people saying, you're taking away our jobs. I want to carry those bags from one point to another. And now this vacuum cleaner is going to take us all out of a job and I have a family to feed, right? Yeah, It doesn't make sense. But what that actually enabled was the port to be more efficient, for it to be able to do things that it wouldn't be able to do otherwise, and thereby setting the stage for the world that this is a very efficient port, and at one point was the biggest port, is now looking to be the most efficient port.
Okay, but last time, I admire your technology and your work. Let's get that straight.
Yeah.
I wasn't talking about unemployment. I was talking about lived experience.
Yeah.
What is life like for people, whether they're in a job or not, but just in the port and around the port? What do they see and experience and feel? What are they doing? And what does that mean to them?
Yeah.
And I really wonder for these people on your AI ship, if that really is better. So would they feel enjoyment on being on your AI ship, or shouldn't they be there at all?
Um,
Or I don't know, should they be somewhere else, and what are they feeling?
I don't think I have a right to say what they should be doing, and I think there's pleasure in the work that you do, and but that's not really something I feel like is what we're working on, right? I see where you're going, but I feel like that you could say that about a lot of things, and it would be hard to kind of answer that, right?
I think it's definitely like a discussion to keep following. I'm first going to go to this side. I'm going to go to this side.
Yeah, so I have a question about like sort of the like when is going full AI? Because I know from the previous experience I have on ships is that there's so much talking, like actual human talking, and the whole time they're connecting with each other, communicating. Like, no, you have to go starboard now, or you have to go the other way, or this or that. And I don't see that happening when there's one artificial intelligent automated boat. Like how are they communicating with that vessel that, that might be dangerous in the other way because vessels try to call that, boat.
Yeah.
And how you're planning on that?
Yeah, this is something that I really like. So communication. So if I got you right, you're talking about you're in a ship and you need to communicate quite a bit, right? So there's the intent of other vessels. You have discussions internally about how ship things should go. So for me, that's actually something that I really really like. And at home, I have Alexa and Google Home, which my girlfriend hates. And I'm always messing with it. So I was like, hey, Alexa or Google, can you switch on the TV light? And then it's like, oh, in Germany, the news is, and then it totally didn't understand me, right? But I have the confidence that one day it's going to have an update and that it's going to fully understand what I'm saying. And in a lot of cases, that's already the case. Like that is, I'm pretty sure, I'm willing to bet that's how it's going to go. You're going to get a system that's going to completely understand the context of what I'm saying things. But to answer your question, yeah.
Like there will be a long time when there's it isn't aligned, so there's some automated vessels,
Yeah.
there's a lot of old stuff still there,
Yeah.
human people still navigating, and the AI doesn't understand human voice perfectly. I don't see that happening together. Like
Yeah.
can it go next to each other? Like can it,
Yeah.
you know what I mean?
Well,
Like,
there's a whole transition period. Like the way a fully automated port would behave would be completely different from how an autonomous boat behaves in a port with people. So right now we look at how do you interface with people, how do you communicate with them, right? So first we simplify the process. We say, okay, if we can figure out how people are coordinating things, then we can actually also see what's going on. But there is a currently, if we deploy a ship that is autonomous, they would have an operator that would handle all of that, right? They might not be on the boat, but they'll be able to handle that. So a lot of it is radio communication and expressing intent and things like that. And then you could have that, and they would not have to be on the boat as long as they have good quality data reception for the journey. But in the long run, I do see systems. I have many ideas, and I should probably not talk about them. But I do think that you make a really good point about, okay, well, how do you deal with humans and the way that they make choices? They don't follow algorithms. And that's essentially what we're doing is we're using the history of human behavior and trying to capture that into a model. And then where it would fail, we would try to have a human that would counter it. But we're trying to make the job so easy for a human that they can actually monitor uh, various boats, right? So all we need to do is just make the whole pipeline easier, and then eventually one person would be able to handle a lot of responsibility.
All right. Let's switch over to online. There's a question from Gordon. Go ahead, Gordon.
Hi there, can you hear me okay?
Yeah.
Hi, greetings from Portsmouth in the UK. Hi, you'll have to forgive me, I'm afraid I'm a bit on the back foot because I unfortunately missed the start of your presentation. But I had a quick question, which was, what's your view on the assistive roles of AI with emphasis to enhancing human intelligence rather than replacing it?
Well, that's the core business plan, right? It's enhancing human intelligence. So we're not replacing. I don't. We're just making it so that one person can actually do a lot more, and eventually that will be being able to handle various ships at a time. Enhancement in the short run looks more like sensor fusion. So if I see if I'm a captain, I can't look 360 around my boat. I can't have eyes around my boat, and I can't do that. I can't analyze images 10 times a second, and at the same time calculating the trajectories of vessels which is within 2 or 3 kilometers range using radar, and at the same time looking at the AIS, seeing if it's valid. But an algorithm can constantly be detecting objects, saying, hey, this is the same object as that object, and this is, I'm really sure that there's an object gonna be here, anticipate what that boat's gonna do, and then if you know where that boat's gonna be, then you can already start planning ahead. And that's essentially giving a human superhuman ability. And that's the short term, that's what we're doing.
Great, thanks very much.
All right, next question.
Hi. I was wondering, what's the biggest challenge you're facing today?
There's a lot of challenges. The biggest challenge? Well, when you're making something, you got to keep in mind that most of the time it's not working. It's not working until it's done. So I think it's just a matter of, I don't really focus on any one problem. I just focus on the next problem. So I think we're in a really good position. We're lucky enough to be in the port of Rotterdam, and I think that's the coolest place to start autonomous shipping. The infrastructure is great. We have the opportunity to work with really amazing people, so that really facilitates a lot of these things. So it's hard for me to say what's bad, but I can definitely tell you that the bad things are a matter of getting them done, you know.
Are these challenges mostly from a technological point of view, or regulatory, or other things?
Yeah, so I think one of the last big pieces of the puzzle was how do you capture call regs into route planning? Like, how do you create routes that are actually realistic? How do you create waypoints? We don't believe that you just put in a few points and that you can follow them and get to the destination. You know, that's not realistic. That's not how we do it. We constantly calculate new trajectories, and that was, I think, the big one, the last big challenge. The rest of it is just engineering. It's a function of leveraging what's already been discovered. Yeah, which also has its challenges. Don't get me wrong; it's very frustrating. But I think it's just a lot of it is that just engineering problems.
Thanks.
Yeah.
Any more questions? Maybe it's also nice to involve well, Kees a bit. So Floris, I'm gonna give you the mic first, and then I'm gonna invite you up front to ask your question and to get some discussion going.
Yeah. Okay. So I've got a small question. I think with a big answer. I'm sure in the future you won't be the only Captain AI or AI captain out there. There will be different ships using different systems. How do you see this will communicate in, one big AI shipping fest?
Yeah, that is the case, and there's some really great other projects going out there, and I think it's really cool that other people are working on it, trying to express how they think is the right way to go about it. I think eventually, depending on the development of other players, let's say, we would collaborate. So we do really good in the pathfinding side, maybe, and someone else does better in controls. Or if that collaboration makes sense, then we would do that. Otherwise, I can also foresee um, kind of how you see the whole online infrastructure nowadays going. You've got cloud services for all different kind of things, and you have a lot of companies leveraging these cloud services. So if you want to, let's say, do predictive maintenance, right? You need to have ships. You created the best new algorithm for predictive maintenance. You need access to ships. You need access to data, and we have a platform for that. So if you wanted to start a predictive maintenance company, it's very easy. You just talk to us, and then we will help you do that. We don't care about making money on predictive maintenance, right? We just want to be able to do things a little bit more efficient. So I think there's going to be a lot of mix and matching. If there's competition in the space, it's good because there's not much competition in the space. I know there's a few guys right now online that are on the same trajectory, but you know, if you look at the automotive industry, how many projects are working on that, right? There's countless now. In the maritime industry, I think there's only about 4 or 5 serious players. Yeah.
In a few years, there will be a ship coming in from Singapore in a few years, and it has to communicate with your ships.
Yeah.
Are you thinking about some kind of protocol? Are they communicating via the cloud, or are they? Well, maybe you have a transponder that's. They should be talking some kind of the same languages, right?
Yeah.
So well, now there's some competition, but in the future there will be a lot of companies developing autonomous ships.
Yeah.
How would well the question was how do you see this happening with communication?
Yeah, I think exactly like that. Like someone in whatever country has developed an awesome automated system. They come into the port here, but they have to kind of abide by certain standards, I guess. And then they would either have to meet certain criteria. Maybe they could use kind of a hybrid system. Like nowadays, like there's a lot of things to be done, but these kind of problems are the kind of problems that happen in doing it, right? So when that first boat comes in, and when that boat needs to face this situation, you know, that's when the answer is the clearest. You know, just use this API or just you know, abide by some standards. I guess that's what's going to end up happening. Yeah.
All right, Kees, can I invite you up front to ask your question? And then we have 2 more questions from the online audience, and then I think we should be working towards a wrap up. But make sure that if you have a question, that you find a way to ask it. So, Kees.
Yeah, my question is actually in both the area of Floris and the lady in the back there, is that the protocols used for automation in the shipping industry are maybe not aligned enough. And then you get this kind of conflicts. Someone develops something on one side, on the other side, and how are you going to deal together on that? That was an issue in aviation as well. And I think one of these solutions was that there were standard protocols. And aircraft not equipped with certain equipment were not allowed to enter certain airspace to mix together. It's still, in a way, it's still the case. And the what do you call it, the AIS?
Yeah.
And the transponder were quite different, I understand, because the transponders we use for communication. Without transponders, we are not allowed to come in certain areas, like Schiphol or airways or whatever, because we don't communicate. And the communication is not position. It's predictive. It's prediction. It gives all the information. Your heading, your altitude, your speed, all the information is exchanged and is worked into the future. And I don't see that so much in the AIS. And that's the only way you can have different aircraft types with different speeds, with different operational issues in the same airspace. And that must be possible, but it has to be regulated. The airspace has to be regulated, or the harbor maybe, and the equipment on board of the ships which are allowed to come in those areas have to be regulated as well, I think. Yeah, that was my question.
Yeah, yeah. I think that's. Yeah, but yeah, it's also a very good point.
But like, are you gonna make a transponder then?
Oh, so I think right now we are looking more at network internet kind of solutions. We don't really need to use transponders. We can send like the data that a transponder would send over the internet, and that's becoming more realistic.
Okay, let's go to this side to online.
Yes, we first have a question from Martijn.
Yes. Hello. Thanks for your presentation. Very interesting. Yeah, my name is Martijn. I work for the Harbor Master division. So from the Harbor Master perspective, we're always interested also in what's allowed on the waterway and what's not. So I heard a very interesting solution on how to combine autonomous sailing with the human sailing, where you said that the port will be fully autonomous or not. So it's 0 or 1. However, now we are in a time where we have the herziene Rijnvaartakte, which says that the river should always be open for all vessels. So also the human vessels. What are your thoughts on that?
So one more time, there are two questions. Can you repeat them in short?
So basically, the law says that the river should always be open for vessels sailed by humans,
yeah.
Which says a fully autonomous port is not possible legally.
Yeah.
What are your thoughts about that?
Yeah. So the world is gray, right? There's no black and whites. So there is, like, the very far future would be, mostly automated. Near future is mostly non-automated. How do you get there? How do you transition to the next? Legally, humans can only go through a place, and then I guess there's a lot of limitations what autonomous ships may be able to do. But I think that is there's a strategic way that you kind of roll this technology out, right? We're not. We start off with showing benefits from a safety standpoint. It's like you're not going to implement full autonomy if it doesn't meet the promise of everything that we want it to do, right? And then by the time that it actually does increase in efficiency and in safety, then it's the natural choice to make that the right choice, right? So is it safe enough for an autonomous boat and a pleasure ship to go in certain areas? Well, let's try it. Let's get the data. Let's see what the results are, and then iterate. Eventually, you'll see that I think a lot of these technologies will be very efficient because it's kind of like the elevator, like, can you imagine if someone was still pulling up a cable, no, I'd rather have that thing automated, right? So I think it's not like we want to push automation, like we have to earn automation. We have to make sure that it's safer. We have to make sure that it passes all these things. That's the point of doing this, right? Yeah.
Yeah, thanks. So I think what you're saying is public acceptance is maybe more important than the technology?
Yeah, I don't want to say that. um, it's like a thought I think a lot of people have. But it's like I think like if you were just to think right now, okay, autonomous ships, what about this, what about that? There's a lot of what abouts. It's when you get that update and things get just a little bit easier and a little bit more efficient that you don't really notice the change, right? And then all of a sudden your kids are playing with cell phones, right? So it's like it will come gradually, and it would have to be earned, and it would have to be, um, it would have to be, I guess, in a sense, adopted by people because that's who we're doing it for, right? In the end of the day. Yeah.
Okay, thanks.
Maybe I can also ask the question to Kees. Like, if you look at the history in aviation, do you see like examples which are very close to this one?
Um, sorry, let me think a bit about it. You mean the mixing
Of
or the freedom of movement? Because I didn't get the first question.
More like the public opinion. Like for instance, there are many different thresholds that need to be overcome in order to go to full autonomy. If you look at aviation, that has it's a bit.
We addressed it a little bit in my talk. Uh, People have to adapt to aviation. It's a question of switching the mind, education, and also trust in the equipment you're building, in the proven safety of the equipment. Because in aviation, actually, automation increased safety enormously, enormously. Huh? And so you need to have the trust in the design, in the testing, and also in the risk management and other hazard management situations where you can predict that the stuff will work and you can trust it. It's a process. Took 50 years or so in aviation. I don't know how long it's going to take in shipping.
How long is it going to take for shipping, Gerard?
I'm working on it.
Okay, right. There's one more question that's going to be asked online. By Martijn.
Let me see. I have to spotlight the video again. Yes. So we have two more questions. First one is from Jan. And it's Jan says, you're talking about sensors. How well equipped for the tasks you want to accomplish are current boats? So that's a question to Gerard.
Yeah.
But if you want to automate the current fleet, what needs to be done?
Yeah. Well, boats are big and they come in all shapes and sizes. And also it takes really long to manufacture these boats, right? So there's that challenge. But on the flip side, most boats, or a lot of boats, a huge portion of boats already have radar. And that comes right out of the box, right? No other vehicle that is looking to be autonomous just comes out of the box with radar. And then also integrating cameras, the cost of cameras are going quite low, and I think that would be quite easy to do. So I think it's a matter of lowering the cost on certain things, which we've been working on. So getting your heading, for example. Right now, if you wanted to plug and play and get direct controls, you'd need to have about a $10,000 or $20,000 IMU, which is like a fiber optic compass, which is what they use in airplanes. But you don't really need to do that. If you have the right algorithm, you can get the same quality data with lower cost sensors. So now we can actually leverage something that's a few thousand, 3,000, 4,000, that before used to be more expensive. So I think the cost for a kit will be somewhat. It has to be somewhat realistic for it to gain scale. But then you're also looking at an industry where the cost of equipment in general is very high, right? So it's in proportion to the investment in a ship, it's actually not too much that you'd have to make. I hope that answers your question with regards to the sensor suite and ships.
Yeah, let us know if it doesn't answer your question. Next one.
Yeah, so we have one more question to close off with, and yeah, we have a little bit of risk of getting into the bullshit bingo, but the question is, ever thought about using blockchain in combination with AI, so we know that AI is not used for the wrong or in a way that is not supposed to be?
Blockchain question. Not my first. Uh, so blockchain is interesting in itself. There's really there's really interesting things about blockchain. I mean, it solves a lot of problems that I think need solving. But currently we're not going to touch that subject. So I think it gets a lot of bad rep also, just because of a lot of scheming. Maybe the origin of blockchain is kind of dubious, right? But from a practical standpoint, I can see a lot of ways in the future where that could resolve some issues. Yeah.
All right, I think those were the questions from online. Is there like a last question from the audience here? Yeah.
Yeah, do you think the port is gonna need to play a role in either demanding or forbid certain things ships do or how they sail to be able to actually like implement and get an autonomous port?
Yeah, well, they've already showed their enthusiasm. I mean, there's a reason why we're actually working with the Port of Rotterdam. I think they're very smart. They look ahead and they try to get a good idea of how things are rolling out. You know, if everyone knew how it would look like exactly, you know, it's just a recipe you're following, but it's not like that. So it's I'm happy that there's someone or there's an entity like the Port of Rotterdam that's taking that initiative, and yeah, definitely they'll need to see how the regulations roll out and they handle a lot of the VTS operations and that I think could also benefit as long as it's safer. Yeah.
You think that's going to be in the near future that it's actually allowed to sail with a autonomous ship, or take a while?
Yeah. So I think the engineering is actually just a function of time, right? Like I think it's just things we need to do, and then it'll get done. It's not. There's no open questions there. You know, who's going to be like? How many people want to be? You know, first ones to try, right? I think that's a lot. So how fast? How fast is that going to take? Well, I think it's in a sense it's also going to be a little bit gradual. You know, there's going to be, I would say about. Okay, I'm going to throw some numbers now. So I think about 4 years or 5 years for everyday autonomy to be working at a certain extent in the port. I'm like pretty sure about that one. I hope so. And then, but I think after that, there's going to be a lot of changes, and I think to get to that point, we're also going to be doing a lot of other things of value. So, like for example, our route planner that was unintended but necessary and of value, which is helping us get to the next step in deploying wide-scale autonomy. Yeah.
All right, I think it's time to round it up for today. First of all, I would like to thank our speakers one more time. Let me get into the screen with you guys. Yeah. So Gerard, Kees, thank you very much for today. Let's give them one warm applause. I also would like to invite Maria, just going up really short.
Watch out, Corona. Oh yeah, the perspective. I don't get it. I feel like she should be in the camera. Yeah.
Okay, there you go. But I'm ahead.
Yeah, that's funny. Right.
Thank you everybody for joining, and let's hope we see you next time.
I also want to thank Jurjen today for doing the technology. Can you put the camera on yourself for a bit? Let me help you with that. Yes, of course. Like this is our tech team sitting right here, answering all your questions. Let's give him a warm applause. And I think to round it up for today, like I'm not sure I'm gonna say it right, but we need to build better technology. We need to train people better. What am I forgetting?
Yeah, I think we learned in aviation from shipping. I think it's time for shipping to learn a little bit of aviation. Uh, there's a lot of commonality, even in the equipment we use. So yeah, there should be, and then there is of course the regulatory side, what you can do in harbor of Rotterdam and not. So yeah, we could talk.
Okay, let's see. 5 years on the bombshell. Thank you very much.
Yeah.